Today we're going to look at our fifth and final method for solving quadratic equations, and it's called using the method of the quadratic formula. Before we get started, let's warm up and review by listing our perfect squares 1 through 225. So we obviously are going to start with 1. 2 times 2 is 4. 3 times 3 is 9. We've got 16, 25, 36. 7 times 7, 49. 8 times 8 is 64, 81, 100. 11 times 11 is 121. 12 times 12, 144. 13 times 13 is 169. 14 times 14 is 196. And 15 times 15 is 225. So there's a list of all of your perfect squares, meaning if I take the square root of 49, it's a perfect square of 7 because 7 times 7 was 49. So little reference sheet there because maybe you've looked down below. The quadratic formula does include a square root, so this can help on some of those perfect squares that we're familiar with. Now, the quadratic formula can be used to find those solutions, zeros, roots, x-intercepts, all of those things that we've been working with lately with these quadratics of any quadratic function. Maybe you've noticed that some methods for solving a quadratic equation is easier or better for some equations versus others. So the quadratic formula, however, will work for any. So it doesn't matter what it looks like. I can use it and it'll help me find my answers. Now, the quadratic formula itself does look like a lot. Here it is right there in the center. It is negative b plus or minus the square root of b squared minus 4ac. And that 4ac right there is all getting multiplied there. See how they're bumped up? All divided by 2a. Notice all of it is divided by 2a. So a couple things there. Now, this quadratic formula, you actually need to memorize because it's not on our reference sheet for our EOC. One positive takeaway is we still use the quadratic formula in Algebra 2. So if you do take the time to memorize it here in Algebra 1, you'll be ahead of the game when you get to Algebra 2. I wrote here on the notes with the asterisk that yes, you must memorize this quadratic formula because it's not on that reference sheet. And then the function must be in standard form, y equals ax squared plus bx plus c, before you start using the quadratic formula. We're going to use our standard form, ax squared plus bx plus c, to get that a, b, and c that you see being used in the quadratic formula. So our steps are, if needed, set that equation equal to 0. Get it set up into standard form. So let's start by working with number 1 and walk through these steps. Number 1 is already set equal to 0, x squared minus 7x plus 12. And so step 2 is to identify that a, b, and c from our standard form. Now, in number 1, there's an understood 1 here for that a. There's a negative 7 for b and a 12 represented for c, or the constant. So I'm going to list that off to the side. A here is an understood 1, b is a negative 7, and c is 12. And we're going to use that quadratic formula. We're going to start by plugging in values into the formula. Step 3 up there. The formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to write it out every time to help you memorize. You write it out, say it out loud. We're going to need to memorize this. Okay, so first we need negative b. So the formula has a negative, plus we are plugging in our b value, which is negative. So I'm going to show all of that. We have a negative 7 plus or minus a big square root of b squared. So I'm plugging in that negative 7 again, and it is all getting squared. Notice I used parentheses here. Minus 4 times 1 times 12, plugging in that a and c value. And all of that I just wrote is under that square root. All divided by 2 times my a, which in this problem is 1. Now you can see we've got a lot going on, guys. I absolutely do not recommend plugging this all in the calculator the way it is right now. I have always told my students, simplify a little bit by hand before you get to throwing things in a calculator, because there's a lot we can do here. Let's start with the negative 7. 2 negatives make a positive, right? So we have positive 7 plus or minus the square root of negative 7 squared. Now, right there, where you have b squared, this should always be positive when you finish. So when I take negative 7 and I square it, I'm going to get a positive 49. That spot right there better always be positive, I promise. Every time, whether the b value was positive or negative, when you square it, it'll be positive. The rest of this, we've got minus 4ac. I've got negative 4 times 1 times 12. I'm going to multiply all of that together, and that's going to give me negative 48. All divided by 2 times 1, 2. Look how much we just cleaned that up. So much better. We can keep going. I've got 7 plus or minus the square root of 49 minus 48, square root of 1 over 2. I can even evaluate that square root of 1, right? That's a perfect square. That's going to be 1. 7 plus or minus 1 over 2. Okay, time out. We have two answers here. Maybe you've been wondering, what's that plus and minus, Miss Bryan? Step number 4, we're going to use that plus or minus from our formula to create two expressions and simplify. We've got two things happening here. We've got 7 plus 1 divided by 2, and we've got 7 minus 1 divided by 2. Two answers, because usually our parabola has two x-intercepts. So for the first one where we use the plus sign, we've got 7 plus 1 is 8 divided by 2 makes 4. There's one x-intercept. In the second expression, 7 minus 1 is 6 divided by 2 makes 3. Second answer. Now you can write this as a solution set with curly braces and show 4 and 3 as your solutions there, and you'll see that notated on Delta Math. So now let's look at number 2. We've got 25p squared minus 5p minus 16 equals negative 4. So no x's. This time it's p. I wanted to show you these examples. Delta Math doesn't always use x. So this time our variable is p, but this still works. Now remember, step 1, we need to make sure it's in standard form equal to 0. So let me add 4 to the left side, giving me 25p squared minus 5p minus 12 equals 0. Now identify your a, b, and c. 25 is my a, negative 5 is b, and negative 12 will be c. And I'll list those off to the side. A, 25, b, negative 5, c, negative 12. All right, that quadratic formula, go ahead and say it, write it out. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Big square root with a lot of stuff in it. Big division. Entire numerator is being divided there. All right, so let's fill it in. Negative b. My b was negative, so watch out there. Plus or minus the square root of b is getting squared, b squared, all of negative 5 will be squared. When I simplify that, that'll be a positive 25. Minus 4 times a was 25 times c, negative 12, all divided by 2 times a, or 2 times 25. Let's start cleaning it up. Negative b, that negative, negative 5, that's a positive 5. Plus or minus the square root of. Make sure that you take all of that negative 5 and square it. That's going to give me a positive 25. I'm going to take all these numbers. I know it says minus 4ac, but that's a negative 4 times 25 times a negative 12. So I'm going to grab the calculator, throw that in really quick. So I'm just going to put in negative 4 times 25 times negative 12 to simplify that last piece under my radical is a 1200. Now it's positive, so I'm going to put plus 1200 over my denominator. 2 times a, or 2 times 25 makes 50. Let's simplify a little bit further. I can do 5 plus or minus, simplifying under my radical. 25 plus 1200 is 1225 divided by 50. Okay, square root of 1225. We didn't list that one at the top, so let's grab the calculator and see if it's a perfect square. Square root of 1225 is 35. So on Delta Math, you're going to maybe see some square roots that are really big. Check them out, see if they're perfect squares. So we have 5 plus or minus. I just evaluated the entire square root of 1225 was 35 over 50. So we've got two expressions here, one with the plus sign, one with the minus sign. First one, 5 plus 35 over 50. If I simplify that, that gives me 40 over 50, or I can reduce that fraction down to 4 over 5. Yes, that's an answer. On this parabola, it's not crossing the x-axis at pretty places. It's actually crossing at 4/5 or 8/10, not quite to 1, somewhere between 0 and 1 on that x-axis. Our second expression, 5 minus 35 over 50, gives me a negative 30 over 50, or I can reduce that down to negative 3 over 5. Again, just not crossing at a beautiful place on the x-axis, just at negative 6/10, so somewhere between 0 and negative 1 on that x-axis. Again, you could write your solution using the set notation here. 4/5 and negative 3/5 are two x-intercepts, or our two solutions to this quadratic equation. Number 3, you're going to do the same thing. First, we've got to set it equal to 0. We've got it equal to 3n squared right now. Subtract 3n squared over to the other side. I'm going to get 6n squared minus 23n plus 20 equals 0. Now that I'm in standard form, my a value is 6, my b is negative 23, and c is 20. List those off to the side. My quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's start filling that in. A negative 23 plus or minus the square root of b squared, negative 23 squared, minus 4 times 6 times 20 all over 2 times 6. Okay, start simplifying a little bit. Those two negatives at the beginning of our quadratic formula is going to make a positive 23 plus or minus the square root of, hey, I don't know negative 23 squared, so let's throw it in the calculator, see what we get. Now make sure you use parentheses around that negative 23 before you square it, because this value should always be positive 529. Know that if I just did negative 23 squared, my calculator is going to think I only want to square the 23 and just have a negative value there. I know, it's calculator weirdness, but I promise. Use parentheses around it just to be sure. So positive 529. And like I said before, that spot after you square your b value should always be positive. The latter part, we've got negative 4 times 6 times 20. Negative 4 times 6 times 20 is going to give us negative 480 all over 2 times 6 is 12. Let's simplify under that radical. We've got 23 plus or minus the square root of what is 529 minus 480. Gives us 49. I like the way that looks as well. All over 12. Now I know the square root of 49, so we're going to have 23 plus or minus the square root of 49 is a 7, all divided by 12. We have two expressions going on here. We've got 23 plus 7 divided by 12, and then we also have 23 minus 7 divided by 12. 23 plus 7 is 30 divided by 12. So we did get a fraction here that we can simplify. They have a common factor of a 6, so we can simplify this to 5 over 2, 5 halves, or that would be 2.5. So one of my x-intercepts for this related quadratic is crossing at about 2.5. The other expression, 23 minus 7, is going to give me 16 over 12, and again, I can reduce that to 4 over 3, or 1 1/3. So our two answers here are 5 halves and 4 thirds. It would be crossing the x-axis at those places if I was to graph this parabola. And number 4, again, it's not set equal to 0, so subtract 2w. Combining it with like terms on the other side, we get 15w squared plus 2w minus 1 equals 0. My a value for this one is 15, b is 2, and c is negative 1. Quadratic formula, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So let's start filling that in. Gives me a negative 2 plus or minus the square root of 2 squared minus 4 times 15 times negative 1, all divided by 2 times 15. Simplifying, I get negative 2 plus or minus the square root of 2 squared is 4. We've got a negative 4 times 15 times negative 1. If you don't know, throw it in the calculator, but it's going to give me a positive 60. And then 2 times 15 in the denominator gives us 30. 4 plus 60 under that radical is going to give us a square root of 64, which is a perfect square. Square root of 64 is 8. So negative 2 plus or minus 8 divided by 30. We've got two expressions here. Negative 2 plus 8 divided by 30 is going to give us 6 over 30, or 1/5 is one answer. Our other expression, negative 2 minus 8 divided by 30, gives me negative 10 over 30, or negative 1/3. Second answer. And you could write it or see it in set notation with our answers 1/5 and negative 1/3. Our last two examples, number 5, solve the equation for all real solutions in simplest form. Let me show you how this one's going to turn out. We're going to follow the same process, just our answers look a little bit different. I'm going to set it equal to 0 by adding 2n squared to both sides. That's going to give me 3n squared minus n minus 5. Now it equals 0. From this quadratic in standard form, my a is 3, my b is negative 1, and my c is negative 5. I'm going to write it over here and get ready to plug it into the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to have a negative 1 plus or minus the square root of negative 1 squared minus 4 times 3 times negative 5 divided by 2 times 3. So let's start simplifying. Our negative 1 is now positive 1 plus or minus the square root of negative 1 squared is positive 1. Then we have a negative 4 times 3 times negative 5. That is going to multiply and give us positive, or plus 60. All divided 2 times 3 is 6. Cleaning that up, in the radical, we've got 1 plus or minus the square root of 61. All over 6. 61. Is that a perfect square? No? Okay, no problem. If your radical cannot simplify, we can actually leave this as our final answer. We can write in Delta Math, and you might see it on your end of course test or on your benchmark test. This can be a final answer. The expression of 1 plus or minus the square root of 61 divided by 6. You do have a plus or minus button on Delta Math. So just because we don't get a perfect square root, it's still an answer. It's still a value. If you typed it in your calculator, you would get a decimal form. And so it's still a place. These directions said to write it in simplest form, so we just left it in radical form. On number 6, the directions read solve the equation to the nearest tenth. What kind of clue is that? We're going to end up with a decimal answer. So let's see what happens on this one. It looks like it is equal to 2a. So I'm going to subtract 2a from both sides. And simplify, we get 2a squared plus 9a plus 3 equals 0. Now that I have standard form, my a value is 2. My b value is a 9, and my c value is 3. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, negative 9 plus or minus the square root of b squared. So that's going to be 9 squared minus 4 times 2 times 3 all over 2 times 2. Simplifying by hand, negative 9 plus or minus the square root of 9 squared is 81. Then multiply together all of that part negative 4 times 2 times 3 is going to give us negative 24 or minus 24, and divide it all by 2 times 2 is 4. All right, we've got negative 9 plus or minus under that radical. 81 minus 24 gives us 57 over 4. Square root of 57, not a perfect square, but different directions from what we saw in our last example. We actually want to get to the nearest tenth. We want a decimal form. So I'm going to evaluate this in my calculator. Now, your calculator does not have a plus or minus button, so we're going to evaluate them separately, just like we did before. I'm going to do negative 9 plus the square root of 57 divided by 4. I'm going to do negative 9 minus the square root of 57 divided by 4 to give me my two answers. All right, for the first one, I'm going to use All right, for the first one, I am going to use those fraction boxes that I love so much. Control and the divide button is going to give me a numerator and denominator, so I can type it in exactly like I see it on my paper here, with negative 9 plus the square root of 57 in the numerator, and then in the denominator I can put that 4. When I hit enter, there's that lovely decimal that I need to round to the nearest tenth. We've got a negative 0.3625 and some more numbers there. Rounding to the nearest tenth, the 3 is in the tenths place, but the 6 tells me how to round. So we are going to have a negative 0.4 as one of our intercepts. And for the second, I'm going to do the exact same thing, but use subtraction. Now, you might want to arrow up to our previous problem and copy it, Control C, arrow back down and paste it, Control V, and then you can just go in and erase that plus sign and put in a minus sign. You might like that feature. We're going to get a negative 4.1374, and we'll need to round it to the nearest tenth. The 1 is in the tenths place of 3, tells me how to round it, so we're going to let it rest at negative 4.1 is my other answer. So again, we had another radical on number 6 that didn't simplify, but the directions were talking about rounding it to the nearest tenth. So we went ahead and evaluated it in the calculator to get our decimal form and then rounded properly. So this was solving quadratics by using the quadratic formula. It will solve any quadratic. Again, we use it in Algebra 2 to solve pretty much all of our quadratics in Algebra 2. So memorize this. Again, that formula is not on our reference sheet, and it can be your go-to pretty much for any problem. You're going to see lots of quadratics on our benchmarks and our end of course test. Practice those, guys, filling that in. The more you work with the quadratic formula, the smaller and less complicated that formula becomes, I promise. Check out the video that I've linked from YouTube about my favorite quadratic formula song. That's my favorite, but there's tons of other songs and memorization tools to help you get that quadratic formula memorized. Y'all practice that. Ask me any questions that you have in class, and I'll see you later.